Let's say I ask you to graph r equals 5 cosine theta. Oh, one term. I know it's a rows. It's a rows of number of petals is 1. So rows of one petal, oh, that's a circle. So I can ascertain quickly that we're talking about a circle. How wide is the circle, or what's its diameter? Diameter equals 5. Well, I already know what this is going to look like. Because it has cosine, we have polar axis symmetry. Remember, our polar axis is simply the new way in polar form of discussing the x-axis. So if I wanted to, now this would be the long way, I could pick theta and get r. When theta is 0, I have 5 cosine of 0. From our unit circle work, we know cosine 0 is 1 times 5 is 5. So if I'm going to graph this in polar form, where this is my polar axis, and this is my theta equals pi over 2 axis, and I've got the pole here, still 0, 0 for r theta. Well, our point here, r theta, is 5, 0, a directed distance of 5 at a directed angle of 0. So that's out here. How about pi over 3? 5 cosine of pi over 3. Well, we know cosine pi over 3 is 1/2 times 5 is 5 over 2, or 2.5. So at an angle of pi over 3, say, we're going to be at 2.5. So we'll call that here. If this one is 5 away, actually it's going to be up like this, isn't it? For pi over 3. So that's going to be about there. What about at pi over 2? 5 cosine of pi over 2. Well, cosine pi over 2 is 0 times 5 is 0. So that gives us this point. If we keep on doing this, we're going to get something that looks like this. Remember, because we have polar axis symmetry, whatever happens above the polar axis is going to be mirrored with what happens under the polar axis. So if I kept on picking points, I would have gotten this and this and this and this and this. And before you know it, I'd say, I think I know what this looks like. It looks like the top of a circle. Well, I could just keep on picking points, or I could use my idea of polar axis symmetry to say, well, whatever's happening above is going to happen below. And you can see, if I picked enough points, then it'd be quite obvious that we're dealing with a circle. Remember, this was r theta 5, 0. So it is, in fact, a circle of radius 5. Sorry, of diameter 5. Now, it's rather inefficient, especially since we're talking about special polar graphs, to pick theta and calculate r each time. You certainly could do that, but I know this is a one-term special polar graph, so I know it's a rows. Rows is of the form r equals a cosine b theta. Remember, a is the petal length and b is the number of petals. Well, if that's 1, a rows of 1 petal is a circle. So I know this is a circle. Now, if this one here, this went out to r theta was 5, 0. That's not xy, that's r comma theta, directed distance, directed angle. That was r equals 5 cosine of theta. And instead of picking all these points again, I'm just going to say, if we do that, say we pick pi, for example. We pick pi, so we have -5 cosine of pi. Well, what is cosine of pi? It's -1 times -5 is 5. So you can see that this point here, 5, 0, has become 5 comma pi. Remember, that is r comma theta. And if I kept on picking points, I would come up with this shape here. So look what happens when we put a negative out in front. Our original shape, which was r equals +5 cosine theta, was reflected over our theta equals pi over 2 axis. So here is our actual graph for r equals -5 cosine 1 theta. Just so we're absolutely clear, this is the graph of negative 5 cosine theta. Notice that we still have its cosine. So we're going to have this polar axis symmetry at the very least because we see cosine is the trig function involved.